Okay, let's see what you came up with. Now, in the past, I've had students in classes come up with the following kinds of arguments. Well, on the edge, it's shallow, and so there might be more algae to eat because light gets into the water better than in the middle. And that's one potential argument. And of course, bluegill don't eat algae, they eat little zooplankton. But if the zooplankton live in the algae, then there in fact may be more zooplankton available. And so the habitat's certainly going to be different in the shallower edge, which receives more solar radiation. It also might be, as some people have argued in the past, that a shallow water protects the young, the small young, better than deep water because larger fish are going to have a harder time maneuvering in it. So that's another possibility. And of course, if there are more algae, it's more algae for the small fry, the tiny fish, to actually hide in. So all these are plausible arguments, and I can't say anything but they're testable hypotheses. We don't have data, and I'm not going to talk about data to test them. But I want to focus on one other hypothesis, and that is that it's warmer in these areas. Because it's shallow, as we often know, shallow pool heats up faster than a deep pool. And because it's shallow, then this warm shore is going to have warm water for the embryos to develop quickly, for the fry to develop quickly, and that's going to speed the growth of the offspring and ultimately perhaps enhance their survival and their fitness. So, if that's the case, we might ask ourselves whether or not bluegill prefer certain temperatures within their water. And so we could test this hypothesis by seeing whether male bluegills prefer to defend an area that's warmer or colder. And so this kind of experiment will be done in a tank of this nature. So you see on this side of the tank, a chiller is pumping cold water in a circular way. And on this side of the tank, a heater is pumping warm water in a circular way. And what that does is create these two separate flows that leaves one side of the tank at a constant temperature and another side of the tank at another higher constant temperature. And the fish can move back and forth and decide where it wants to spend its time. And you can hook up a little camera above the tank and you can record where the fish is and what proportion of time it's spent on the cold side or the warm side. Now, if I had two temperatures, let's say I had like, I don't know, 34°C and 28°C. What I would want to know is the fish spend more time on one side or the other, and if it spent most of its time on, say, the left side, then I would say, okay, it obviously prefers 28°C over 34°C. But now I could say, well, let's change the temperatures and rerun the experiment. So now I'll make this side 28°C, and this side 24°C. And now I might find that the fish spends most of its time on this side. And I could say, okay, well, the fish doesn't want to be as hot as 34, and it doesn't want to be as cold as 24. It wants to be somewhere closer to 28. And then I can keep doing that iteratively until I hone in on exactly what the temperature is that the fish wants to be at, and that would be the temperature it prefers. So here's an experiment that's done by putting a lone male bluegill into this tank, and you could see that the tank had two sides. One side at 27, one side at 31. And then in the second experiment, the tank's temperatures were changed. So one side was 31 and the other side was 34. Now I want you, before we talk about these data, to make your best effort to write a figure legend that describes them. It should be accurate, it should convey the message and any other information needed to interpret the data. And you, in this case, since we're talking about the percentage of time, don't have to talk about error bars or anything like that.